This is going to be the chi-squared test of association or independence. Test of association or independence. And on this one, we do have a condition, and our null and our alternative hypotheses are changed a bit. The null hypothesis is there is no association between two categorical variables. Excellent. I was in fact going to ask the question if anybody remember what a categorical variable is, and color is a good example of categorical, right? Non-numeric. So it has to be a non-numeric variable. And because we're talking about two, that forces us to have two columns. Could be like success or failure. Do you like red? Yes or no? You know, success, failure. So that's an important distinction of this. The alternative, if the null hypothesis is that there is no association, what must the alternative be? There is an association. That's exactly right. There is an association. So it's kind of backwards, where it's sort of saying that it's not equal and then it is equal, or well, maybe it's not. I don't know that it is. It's just a little bit different way of thinking about it because we have the categorical situation here. Conditions, or really it's a condition. All expected cell counts are at least one. Quick side note, look in matrix B, right? I would actually do the calculation, look in matrix B, and then decide if you had met the conditions or not. And no more than 20% or less than 5. That's it. On to an example or a problem. So our notes kind of keep getting shorter, which is good. The problem I want to do is 1422. It's on page 874. And it deals with smoking by parents and students, or students and parents. And the question basically says, how are the smoking habits of students related to their parents' smoking habits? Here are the data from a survey of students in 8 Arizona high schools. So we have some data here. We have parents smoke. and students smoke, non-smokers, and total. So the numbers in this are 2 parents smoke, or both parents smoke, I think is how it's worded. 1 parent smokes, and 0 parents smoke. The data given is that we have 400 students who smoke where both parents smoke, and 1380 for non, for a total of 1780. And for one, I've got 416 that smoke, 1823 that do not, and 2239 is a total. And 188 smokers where neither parent smokes, 1168 for non, and 1356. And I'm going to go ahead and fill out the rest of our total. These would be our total columns. The others are the total row. I've got 1,004 participants that smoke, 4371 that do not smoke, and 5375 total. So I'm filling in some stuff that hasn't been done. So A simply says this is an R and C table. What are the numbers R and C? Got 3 rows, right? Two parents, 1 parent, and 0 parents. And 2 columns, smoke and non-smoke, right? We don't count the totals. Is the question categorical or quantitative? Do you smoke? Do you assign a number to that, or is that a yes or no? Yes or no, that's categorical, right? So we've got categorical data, 2 columns. I'm thinking test of association. Okay. Just kind of throwing that out before we get too far down here. B asks us to calculate the proportion of students who smoke in each of the 3 parent groups. Then describe in words the association between the parent smoking and the student smoking. So for 2 parents smoke, I've got 400 students out of 1,780 total in that category for a proportion of about 22.5%, 0.225. So this is representative of about 22% or 23% of the total in that category. 1 smokes is 416 out of 2239, or about 18.5% of that group are smokers. 1 parent smokes. And the last one, 0 smoke, 188 out of 1356. It's about 14%, 0.139. So I just have to take a little aside here and complain about the English language for just a moment, okay? Because when in English we make something plural, we generally add an S to it, right? So why is it that when both parents are smokers, we say two of them smoke? But when only one smokes, we say one smokes. Shouldn't it be two smokes and one smoke? There's really no logical sense to why English language does what it does or says what it says. So I just have to say that there's no way that somebody coming into this country not knowing English could make any sense out of our language whatsoever. It's stupid. Okay. All right. Now, what do we notice about these values? What might you say about students smoking and their parents' smoking habits? What assessment might there be to make here?
Kids are more likely to smoke if both of their parents smoke.
Yeah, exactly. Or maybe they're more likely to smoke if a parent smokes, right? Certainly,
Yeah.
but yeah, these values are higher. Yeah, exactly. So if at least one parent smokes, the student is more likely to smoke. Now, I don't know when this survey was taken or if it's even real at all, but it seems to me that from what I'm seeing, these numbers are probably lower, at least in this area, I hope, I think. I am a little concerned with this whole vaping thing. I think that's going to turn into quite a mess for a few people that do that. All right. So then they want us to graph the data. So what I'm going to be graphing are these values. So keeping those in mind, I'm going to go to a graph for C. And it's categorical, so I'm going to make a bar graph. And for my y-intercept, I'm going to say percent of students who smoke. And my biggest percent is a little over 20, so I'm going to go 5, 10, 15, 20, and something like that, 25. That'll work. And then we've got parents who smoke. Both parents smoke. That's about 22.5% chance that their children would smoke. If only one parent smokes, that lessens it to a little less than 20, about 18.5. Oops, I got to go up a little farther. And if 0 smoke, that drops it down to about 14%. Just a visual representation. All right, so D says, explain in words what the null hypothesis says about smoking. Let's say, what's the null hypothesis going to be here? It's an association. Yes?
There's no association.
Yeah. But, so be specific about what the two are.
There's no association between the parents who smoke and the percentage of
Whether their kids smoke. Yeah, I agree. So there is no association between parent smoking behavior, perhaps, and their children's smoking behavior. What about the alternative? We've got a lot of context in there. So if there's no association as the null, what's the alternative? There is an association. Now, I don't think you have to recopy all of the context again. I think it's assumed. There is an association. There is an association. All right. E. E wants us to come up with the expected counts if the null is true and display them in a two-way table similar to the table of the observed counts. Okay, so I've got parents and students smoke, no, 2, 1, and 0. Okay, the easiest way to get this, if I'm not mistaken, didn't we put the data in already? Did we? Maybe we didn't. No, we didn't. Okay, so I need to go back to the first page. There we go. And I need to put in the observed. So these are going to be our observed values. So I want to put that in as my matrix A. So that's going to be a 3 by 2. And this is the shortcut for getting the expecteds. So the calculator doesn't automatically make matrix B when you make matrix A. You have to tell it to do the test. So at this point I'm going to go to the test. We want the chi-square test. Matrix A is observed, expected is B. It's going to make that for us. And I don't really care about these numbers yet. I'll probably care about that in a minute or two. But what I want to get back to is the expected values. So where to find those now is to go look at matrix B. So I'm going to go edit matrix B, and there are my numbers. So now I'm going to go back over here and copy those in. So I've got about 332.5. You can do a little rounding. I think that's just fine. And 418.2 and 253.3 and 1447.5, 1820.8, and 1102.7. So those are the expected counts. That's cheating, right? That's the shortcut for getting that. I think if I were doing this for the AP test, I'd probably just make a little note that you got that from the matrix B after completing the test. All right, F. Compare the table of observed and expected counts. Explain how the comparison expresses the same association you see in B and C. Compare the tables of observed and expected counts. So if I'm comparing those, well, if this was our observed and this was what we expect, if they're all equal, it seems pretty clear that there's a difference between the observed and expected. Here we're actually pretty close. And here we're quite a bit less than what we expect. So for the 2-parent smoke, we're more. For the 0-parent smoke, we're less. And for 1-parent smokes, we're just about in line with what is expected. Let's go ahead and do the chi-squared test here. And go ahead and finish this up. So chi-squared test. We're going to get chi-squared. And so if I go back to that, I get chi-squared is about 37.6. The p-value is quite small. 0.000000000 about 7. Okay? It moves the decimal place 9 places. And degrees of freedom is 2. Now, is there any alpha that anybody would reasonably set that would make this anything other than a reject the null? This p-value is approaching 0. So we have significant evidence. To reject the null at any reasonable alpha and conclude there is an association between parents who smoke and their children. But I say parents smoking behavior. And their children's smoking behavior.